section 11.6, which is ratio and root test. We do know the ratio test, right? Essentially, just to remind us, you find the limit as n tends to infinity of a guy called an plus 1 divided by an. You should take its absolute value, and it will equal something, right? And the test says that if L is greater than 1, something is true. If L is less than 1, something is true. And if L is the number 1, it is true. Okay, suppose this is a number bigger than 1. Suppose the limit ends up being 7 or 47 or whatever. What conclusion do you make when L is bigger than 1?
Diverges.
Agreed. And if it's less than 1, the series converges. Actually, you get something for free. Doesn't the series absolutely converge? It converges, but you get a little bit extra. And this one we don't like because this is inconclusive. And I already mentioned yesterday, but I'll remind you again today, that the ratio test is good for series that have factorials in it, right? So if there's an n factorial or an n plus 1 factorial, something like that, top or bottom, ratio test is really the only way to go, right? If there's a lot of 2 to the n's and e to the n's, ratio test is pretty good as well, right? Use it in situations like that. Don't use it when it's n cubed plus n over n squared plus 42n, you know, the polynomial ones, because you almost always end up with inconclusive, right? You can do the test, but you don't get any answer out of it. So that's kind of wasted time. I recollect doing, but not recollect how many situations. So by any chance, did I do a question with an e to the power in it? Have I done an e to the power one yet? I know I've done a factorial one, but I don't know if I've done an e to the power. Okay, so let me do that as our first example. So an example of that would be question 6 in your homework. And it's going to be the series k equals 1 to infinity. My example, it's that. I would rewrite this guy like that. Just going to make it easier algebraically, like that. So we are going to do the limit as n tends to infinity of the ratio of this guy divided by that guy. And the top fella is this with a k. Oh, well, yeah. It's n is k here, right? So what you've got is 3k plus 1s over e to the k plus 1. Right, that's the top. Divided by 3k e to the k. And I'm now going to have to change that guy to a k and that guy to a k. I wish they wouldn't do that. Would you agree it's just cosmetic? I mean, you could call it any letter of the alphabet. So it's now going to be the limit as k tends to infinity. Since everything is positive, I don't need those absolute values anymore. I'm multiplying out the top, so I've got 3k plus 3 over e to the k plus 1 times, and turn that guy upside down, you get e to the k over 3k. So far, so good. Now what I'm going to do is see if there's anything that can cancel and then combine what's left. Would you agree that this here should be able to interact in some way with that there? Right, and what kind of cancelling do you get when that is on the top and this is on the bottom? So you have an e to the k on the top and an e to the k plus 1 on the bottom. You're cancelling them, right? What's left?
You have an e on the bottom.
Right, and just an e to the 1, which is e on the bottom. Agreed? Now, on the top, we're still going to have 3k plus 3, and on the bottom, we're still going to have 3k. By the way, E is just a number now, so don't let it freak you out. I need to know what this is equal to. You could divide the top and bottom by K, but just to be different, I'm going to do L'Hopital this time. So it's a limit as K tends to infinity. Well, if you differentiate 3K, if you differentiate 3K plus 3, you get 3. And what do you get if you differentiate? I could have called that 3EK. I probably should now that I thought about it. But what do you get if you differentiate the bottom with respect to K?
3E.
And so doesn't this end up becoming 1 over E? Would you agree 1 over E is a number? And would you also agree that since E is 2 and a bit, that 1 over E is less than 1? Okay, what conclusion do you make if the ratio test gives you a limit that's less than 1? What do you know about this series then?
It's absolutely convergent.
And you are finished. Kind of nice test, isn't it, when it works? Now, by the way, if I gave you that same test to do, but we hadn't heard about the ratio test, that would have to be an integral test. And you would have to integrate 3x e to the negative x, right? I would call it. Do you know that would have to be a integration by parts? Wouldn't you then have to make, you know, the t tends to infinity thing and try and do some brute force on it or whatever? Can you just imagine how horrendous that question would be if you had to do an integral test on it? You'd have to prove that it was decreasing, right? You'd have to find a limit from 1 to infinity, which, trust me, is a page and a half. It's a lot of work. And you'd still get the answer. So tests are not exclusive. In other words, one particular series, it's quite conceivable that there could be 3 different tests that would be usable. But shouldn't you always use the test that's the least amount of work? And in this case, between the integral test and the one I've just did, would you agree this one wins? Now, if you did an exam and you went a totally different route and you did the integral test, you would still come to the same conclusion and you'd still get all the same points, but wouldn't you have used up another 15 minutes of your time? And that's important because tests don't last forever. Are we cool with that?
Professor, I have a quick question.
Go for it.
So it's more of like, so you had mentioned that the variables are practically cosmetic. If we were onto a test, like where we would have to show our work, if we ended up just using n instead of whatever letter was put in the original problem, would we be deducting points for that?
Nah, totally okay with that, Jade. If you think, as it did with me, oh God, it should be a K, not an N, and it's, you know, it kind of make, you know, distraction, turn them into N's. I mean, and when I'm saying they're totally cosmetic, what I'm saying is, I think you know what I mean, but just to make it clear, mathematically, 3 lines in math means exactly equivalent to. Doesn't mean it's equal to it because it's not exactly the same looking thing, but it's equivalent to it. And I'm sure this is what you meant, right? So,
Okay,
do
thank
that.
you.
Yeah. Was it just the letters bug you? You just like ends?
Yeah, just sometimes whenever I end up doing a problem, I've realized in tests previously, I end up switching the variables instead of sticking with it just by accident. So
I can have, yeah. Me personally, I like X's when I integrate things, right? The minute they turn it into P's and T's, don't they? Somehow, your part of your brain says, no, that's not the same thing. You have to do it different when it's a P. And the answer is no, it's the same question. It's cosmetic. Cool. Right. I need to remind you of something before we do the next question. There was a truism. There was something I just said, this is true, trust me. Can you remember what I told you this is equal to? That's a hard one because we only talked about it for 2 minutes and moved on. It's very weird what this is equal to, but you have to trust me, it is equal to it. What do you get?
E to the 9.
E, correct. To what power? And that looks like a 9, but it's actually an A.
Oh,
A
then it
times
would
B.
be E to the A.
Just A?
A over B.
I can move it.
AB. There we go. It's equal to E to the AB. So if you get a question that looks like this, or if that, won't that just be E to the 1 times 1, which is just E? Okay. Now, the reason I'm telling you that is that that's going to happen. So here goes. We are going to find, oops, start again. We are going to check, and this one is a version of question 8. Sigma n factorial over n to the n from n equals 1 to infinity. So it's going to be the limit as n tends to infinity of an plus 1 over an. Since everybody's positive, I'm going to lose the absolute values again. And this is going to be the limit as n tends to infinity of n plus 1 factorial over n plus 1 to the power of n. God, that's ugly. Divided by n factorial over n to the n. Now this is going to be the limit as n tends to infinity of the top one unchanged. Oh, by the way, that n should be n plus 1 as well. To n plus 1 to the power of n plus 1 times n to the n over n factorial. Do you agree this is ugly? I almost missed my n plus 1 here, right? Now, one of these two, and I'm just going to rearrange this to make it a little bit easier to show you how I'm going to work with it, is I'm going to take these guys and stick them one above the other. And then I'm going to take these two guys and stick them one above the other. Because really, if you're going to do any kind of simplification or cancellation, shouldn't you have like with like? And all I'm doing here is rearranging them so it's a little bit easier to see who goes with who, right? So there are two distinctly different problems. I have to figure out what that becomes in its simplest form, which is pretty straightforward. And then I have to figure out what that becomes, which is by no means straightforward. And it's going to use this. So I'm going to switch places. I like things to be on the right-hand side than I right. So let's just do the simplification of that guy. Now, I said that one was pretty straightforward, but just to remind you how it would work, 1, 2, 3, all the way up to n plus 1, and just before the n plus 1, wouldn't there be an n? And on the bottom, it's 1 times 2 times 3, all the way up to n. And when factorials play, don't they play well together? They tend to cancel a lot. In this particular question, would you agree that the answer is n plus 1 is left, and it's on the top? So this guy is n plus 1. If you want to call it n plus 1 over 1 because it makes you feel better, that's fine. Now the horrible one. We are going to do some algebra here, which I don't think you've ever seen before. I'm going to try and figure out what this can simplify down to so that I can eventually make n go to infinity, right? And get the limit thing, right? And use that. First thing I'm going to do might not look very helpful, but it is. I'm going to take n plus 1 to the power of n plus 1 and rewrite it as n plus 1 to the n times the other n plus 1. Would you agree these two bottoms are equivalent? Now I'm going to do is take these guys and combine them. and then stick that guy over there. So far, so good? Now, this guy doesn't look like this guy yet. Would you agree? So I am going to do this. If you take something and you make it a negative power, don't you essentially take its reciprocal? Do you see if you turn this upside down, but make that a negative power, isn't it equivalent to the top guy? That's the new thing, but that is mathematically allowed. As a number, if I said to you 2/3 to the power of 3, it is equivalent to 3/2 to the power of -3. That's kind of what I'm saying. So it makes sense when you see numbers, right? Now, this is getting dead close to this fella. If you now separate them, n over n, and this guy, you get that. So believe it or not, this is what I want that to be written as. So return here. It's going to be called 1 plus 1 over n to the negative n times 1 over n plus 1, right? So that guy is him. Now, do you notice this cancels that guy? And now we are left with what does that equal based on this truism? What does 1 plus 1 over n to the power of -1n get you? E to the power of what? Be careful.
-1.
Now, it isn't e to the -1. Oh, by the way, 1 times -1 is where that came from. Isn't that 1 over e? Agreed? Is 1 over e bigger than 1 or less than 1?
Less than 1.
And because it's less than 1, does it not mean that this is absolutely convergent? That was a pretty messy piece of algebra, wasn't it? But it came out with an answer that we could end up using. Before I move on from this question, is there anything that you'd like me to maybe explain or re-explain?
I have a question.
Yeah.
Like just in general, like how should we be thinking about making the process to go about these? Because like that was definitely some weird algebra. In general,
Yeah.
are we trying to just kind of split terms and keep splitting it? Because the more we split it, the more it simplifies.
My goal here was to try and take this guy was causing the problem, essentially, right? And so my goal here was to try and find a way of rewriting this fraction that used those guys. Where is it? Here. This fraction that used those guys and finding some way of rewriting. I know from experience that whenever you deal with an n to the n world, right, like here, you are going to end up with one of these. So I kind of know that that has to eventually turn into something that looks like that. So that was me just through experience and realizing that that's the case. When I have factorials, don't factorials play well together? So I know how to deal with factorials. Keep moving the wrong place, right? Don't n cubes and n plus 1 cubes behave pretty well? You just do, divide the total by n cubed. So it depends on the things that are in the series, how I'm going to tackle it. So whenever you see an n to the n, you are going to end up doing something like this.
Okay, so that was your question. You saw the end of the n, you knew it would be that formula, and the puzzle is how do you get that into that formula so you can use it?
So
Okay,
I just
cool.
play a bit with it, and I kind of know what it's going to look like, right? It's going to look like that. and I have to figure out how I make it look like that.
Awesome. That totally answered my question. Thank you.
You're welcome. It's messy. Try pick another question, maybe not quite as messy. Well, we only have one left, so here's my version of question 9. N equals 1 to infinity. N the 40. 40 to the power of n over n factorial. This question's quite good because it has 3 of the 4 features. Don't you have some questions with n cubes and n squared in it? So that's that guy, it's just a big power. Don't you have 2 to the n and e to the n and things that look like that? So 40 then is this. And don't you have questions that have factorials in it? The only thing that's missing from this is an n to the n guy, which I'm glad it's not got that, because that would just make the question huge. So I'm going to go and do the limit as n tends to infinity of an plus 1 over an. In this case, it's going to be quite big. So it's going to be, let's see, n plus 1 to the power of 40 times 40 to the power of n plus 1 all over n plus 1 factorial. So that's the top. And on the bottom, we're basically just getting this guy. So n to the 40, 40 to the n over n factorial. Do you know if a couple of days ago I had gave you this, wouldn't you run out of the room screaming? Would you look at it now and it ain't that ugly once you've seen enough of them? You just get used to them. So in this case, I don't need the absolutes because everybody's positive. It's going to be that guy again. Turn the other guy upside down. And when questions get big or just complicated, I would put a line like this in. Some people don't need this line. That's fine if you don't. And do you see, I'm just rearranging them so like things are above each other, right? And now what I need to do is take each one and figure out what we get. If you take n factorial and cancels it with an n plus 1 factorial, what would be left and would it go in the top or the bottom?
N plus 1 in the bottom.
Right, so we would write that guy like that. Are you comfortable where that came from? Okay, 40 to the power of n plus 1 and 40 to the n, would you agree they cancel? What's left, and does it go in the top or does it go in the bottom?
It would be 40 on the top.
And since that's on the top, I can just write 40. If you're a purist, 40 over 1, it makes no difference to me. Now, this fella here, I'm going to do it beside. N plus 1 to the 40 divided by n to the power of 40. Now, we know we're going to try and find what the limit of this guy is. And, but right now I'm just focusing on what it is equal to in a form that's going to make it easier to put in here and then find its limit. Now, since they both contain 40s, I'm going to do that. And a word of warning, this is not the E guy. It looks like the E to the 40 guy, but it's not. Do you notice that that is just a power of 40? It's not 40n. If it had been 40n, wouldn't the answer be e to the power of 40? Great. So that doesn't have any n in it. So this is not that situation, even though it looks like. So I've now rearranged this guy and I've called it 1 plus 1 over n, right, to the power of 40. Are we comfortable with what I've done to each of the three terms? Okay, let's do brute force now. This guy becomes 1 plus 1 over infinity to the power of 40. This becomes 1 plus 0 to the power of 40. This guy is just 1. This guy is 40, and he's always been 40. And this guy is infinity over 1, which is 0. And 1 times 40 times 0 gives you 0. Would you agree that 0 is less than 1? So conclusion, this series is absolutely convergent.
Professor,
Yes.
could you have assumed that since there was 40 powers of n on the top and 41 powers of n on the bottom, could you just divide by 40n and do that instead? I'm 41.
Divide by n to the 40 top and bottom?
Yeah.
That approach would work equally fine, yes.
Okay.
We're good with that, guy? Going to move on to the ratio test, which is our final test. Okay, that works. So, oops. Don't need it. We're now going to do the nth root test, or as this book calls it, oops, the root test. And it says, for any series, n equals 1 to infinity, an, if the nth root, oops, you find the limit of n tends to infinity of the nth root of an. And it will equal a number. And it has the same pattern here. If that number is bigger than 1, the series diverges. If that number is less than 1, the series converges. And if it's equal to 1, it's inconclusive. So we're going to find algebraically the limit of the nth root of something. Now that is pretty messy looking, except this is a very restrictive test. You should only use this test when an, right, the an guy looks like this. Should only use it when it has, pick another example. When it looks like that. Or it looks like that. So do you notice what makes this test work is, for the most part, don't you have an ugly thing to the power of n, or an ugly thing to the power of 2n squared, right? Or an ugly thing to the power of n. They all have that shape. You would never use the nth root test for, you know, n cubed plus 1 over n squared, right? You would never use it for, you know, e to the n over 2e, well, I guess you could use it for that one. E to the n over n cubed, right? You wouldn't use it typically for a situation like that. So it has a niche market, right? There are only certain series that you would ever use it on. So let's show you some examples of that happening. So technically speaking, there's an absolute value around that. I guess I should put that in. So pick a version of 11. Let's suppose I'm interested in that guy. Then, according to the nth root test, you are going to find the nth root of that guy. So it's going to be the limit as n tends to infinity, the nth root of this fella. Do you notice that I basically get rid of the negative right away? And there are good reasons for that. You can't find square roots of negative numbers, right? You can only find it for cube roots and so on. So the absolute value just basically says, if it's negative, pretend it's not. That's how I would look at it. So algebraically, what happens to this when you take it to the nth root? What does it become? The nth root of something to the power of 6n.
Wouldn't that just become to the 6th power?
Yes. So if you want to think of it like this, the nth root of something is that something to the power of 1 over n, right? So if you have the nth root of blah, 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 blah to the 10n, don't you basically have 10n raised to the power of 1n? Do you see they essentially cancel? And you get that. So a quick way of looking at that is, won't an nth root kill off an n? An nth root will kill off a power of n. Now, this guy here is not that hard to do. I could rearrange the order. In other words, find this guy here first, and then raise the answer to the power of 6. This guy here you could do with L'Hopital or divide top and bottom. You'll get 3, and 3 to the power of 6. I don't even care what 3 to the power of 6 is. Would you agree it's bigger than 1? And if it's bigger than 1, conclusion, the series diverges. So you find the nth root, basically kill off one of the nth powers, and boom, get a number. And if you can show me the number is bigger than 1, the series diverges. If the number that you get is less than 1, it converges. And if you get some other situation like equals 1, then it's inconclusive. Let's show you another one. How about this one? Sigma n equals 1 to infinity. 2 times 1 plus 1 over n to the power of n squared. So this is going to be the limit as n tends to infinity of the nth root of that expression. If there is more than one term being multiplied together, as we have here, it's a good idea to split them. So that becomes 2 to the power of 1 over n, nth root of 2. And this guy becomes that. And we now have 2 to the power of 1 over n times, well, that cancels one of those. Okay, first time you've seen it. The nth root of 1 plus 1 over n to the power of n squared. What does that simplify down to if you take the nth root of something that's n squared?
It would be n.
Correct. If it was n cubed, wouldn't it be n squared? And so on and so forth. Right, so we've algebraically converted this expression into this one. Now I should be able to do brute force. And isn't that 2 to the power of 1 over infinity, which is 2 to the power of 0, which gives me the number 1. And hopefully you recognize this guy. What does this guy get you when n goes infinite?
e to the power of -1.
-1 or +1?
Oh, sorry, +1.
Okay, which is just e. And isn't 1 times e just e? Oh, another bigger than 1. So this one diverges. Are we good? Any problems with that one? Okay, let me do another one. Let's do n equals 1 to infinity, 3 to the n, 1 plus 1 over n. No, make it 2 over n just to be different. All over 10 to the n. That's nice and messy. And I'll make this negative 2n squared. Okay, so that one's kind of ugly. I'm picking it because it is ugly. So we're going to do the limit as n tends to infinity of this guy. So it's going to be, since everybody is positive again, I can just write down this expression. And stick an nth root around it. And then take each piece separately. What would 3 to the power of n be if you took the nth root of it?
3.
Yeah. On the bottom, wouldn't you get a 10? Now, if you take the nth root of this ugly guy, you still get 1 plus 2 to the n, but what power do you get? The nth root of a negative 2n squared power. What do you think?
-2n cubed.
Are you combining it or cancelling it? You're
Combining.
taking,
I should cancel it, so it should be -2n.
agreed. You notice it just knocks off one of the powers when it's that case. Now, that guy's a number, so we're finished. And that guy's a number. And when n goes to infinity, won't this become a number? Well, let's see what number we get. Using my AB thing, what does that fella become? What's the limit of that guy?
e to the -4.
Agreed. If I write this down as 3 over 10 e to the 4, have I convinced you that that's less than 1? Because it is. Do you agree? And because it's less than 1, we have finally got an absolutely convergent. Are we cool with that? See if I can find some more. Too many. Come on, there must be another one somewhere. No, the others full videos. Okay, I'll do. I don't know if I need to do one. Do you need to see another one like this? Or are you comfortable with the nth root test? I can't find any others in the homework. But, I mean, I can make one up, but are you comfortable with that?
I am.
Yeah, okay. So basically, very, very specialized situation. Have you noticed that they all shared some kind of power of n or n squared thing going on? That's typically what is happening here. So returning back to a special question that I saw a moment ago. Here we go. And this is a trick question. But since we've kind of done every test, I think we've reached a point where they should give you questions that don't necessarily belong, right, in the category. Right now, the category is ratio test or nth root test. So you think everybody has to be one of those two. No, they don't. This guy could easily be done other ways. I could do this one with the divergence test. Wouldn't you agree that 2 over n over log n is infinite? And if you don't believe me, do L'Hopital's rule on it. Wouldn't infinity to the power of infinity be infinite? Wouldn't that be, yeah, you are definitely divergent, right? The limit would be big. Right? So I could do that with the divergence test. So that's the bottom line. Not all series need to be done using the ratio test or the nth root test. Could I do that guy with the nth root test? Yes. Wouldn't the answer be 3/10 and it converges? What other technique could I use to check that? What other method could I use to find if that converges or not?
Is it a geometric series?
Yeah, isn't R 3/10 and it converges? So don't get caught up on one method is the only method to use. So that's kind of the story here. If I gave you, in fact, I think one of the homework questions does this. If I gave you that guy, you know, you could make your life really difficult or long by doing the ratio test. And the bad news is after you did the ratio test, it's inconclusive. What would be a better test to do for this series? Yeah, isn't it P equals 3 at divergence? See how quick it is if you see a better test? So you're always going to be looking, because most of the questions are going to be nth root test or ratio test, because that's what it is, right? That's what the section is. But they are throwing in some questions where you don't need to do that test. Would you agree the P series test is a lot quicker and you get the answer? So bear that in mind. Now, a little bit different. I think there's only one example of it. Yeah, well, that's fine. Question 15 says, for what values of x is that guy convergent? So we are interested, when is this fella convergent? So if I do the limit as n tends to infinity, and I'm going to do the ratio test on it, I'm going to get the limit as n tends to infinity of x to the n plus 1 over n plus 1 factorial, and on the bottom, x to the n over n factorial. I'm not going to remove the absolute values here. Could an x be a negative number? Right, there's no restrictions. It could be -10, right? Just as likely as it's +10. So we need to keep those absolute values in check. So untouched top, turn the other guy upside down. This guy will cancel out this guy. What's left, and will it be in the top or the bottom? x to the n plus 1 on the top, cancel again, x to the n on the bottom. What's going to be
Xn.
left? And just call it xn. And then if we cancel these guys, can I put an n plus 1 on the bottom? Now, you may be a little bit concerned, but don't be, that you don't know x. X is just a number you don't know. It's not going to go infinite on you. So when I put infinity in here, can't I just brute force it? Would you agree any normal number divided by infinity is 0? And isn't 0 less than 1? So what does that tell me? Doesn't it tell me it doesn't matter what x is? Won't this always converge? So your answer for what values of x? For all values of x.